So I've had a request to solve problem number 47. I'm just going to do parts A and B since part C is just drawing a picture. When a single filament bulb of a particular kind and two batteries are connected in series, so that's where they go around, 3 times 10 to the 18 electrons pass through the bulb every second. When two batteries connected in series are connected to a single thin filament bulb with a filament made of the same material and the same length as that of the thick filament bulbs but a smaller cross-section, only 1.5 times 10 to the 18 electrons pass through the bulb every second, so that's half. In the circuit shown, where you have a thin filament bulb and then two thick filament connected in parallel, how many electrons per second flow through the thin filament bulb? And then B, what approximations did we make? Okay, so the trick to this one is really just a ton of algebra. And we'll go through that now. And you want to use loop rule and node rules. Let me go ahead and zoom out. Get started. Okay, so we know that I thin is equal to 1/2 I thick when the bulbs are connected to the two batteries. Therefore, A thin must be equal to 1/2 A thick. And then, using node rule, so we know that I thin is equal to I thick plus I thick, since it branches into two different branches. Okay, so NA thin U E thin is equal to twice NA thick U E thick. All right, so these are made out of the same material, so we can go ahead and just cancel the N's, cancel the U's, and we're left with A thin E thin is equal to 2A thick E thick. Remember, the electric field is a part of that current equation, so this is what we're trying to build towards. And we know that A thin is equal to 1/2 A thick, so we want to start getting stuff into terms that are all the same. So we can plug in 1/2 A thick times E thin is equal to 2A thick times E thick. All right, so now we can cancel these out, and you can bring that 1/2 over there, and you get that the electric field thin is equal to 4 times the electric field thick. So and that's where it's branching off into those two parallel paths. All right, so that's as far as we can go with node rule. So now we need to go into loop rule. So we have two batteries, so 2 EMF minus delta V thin minus delta V thick is equal to 0. So we have 2 EMF minus E thin L thin minus E thick L thick. All right, so we can sub in, this is all equal to 0, we're neglecting the other wires. We can sub in node rule because we can put the electric field of the thin wires in terms of thick. So then we have 2 EMF minus 4 E thick L thin minus E thick L thick equals 0. And we're going to assume that L thin is equal to L thick, so they're the same length. So then, making that assumption, we would have 2 EMF minus 4 E thick minus E thick times L is equal to 0. And from here we get 2 EMF minus 5 E thick L is equal to 0. So E thick is equal to 2/5 EMF over L. And also we know that E thin is equal to 4 times E thick, which then means that it's equal to 8/5 EMF over L. And I thin is equal to NAU E thin, which is equal to NAU 8/5 EMF over L. All right, so we still don't have a current quite yet. We want the number of electrons per second. We need a number. And so E thin is equal to 2 EMF over L, and I is equal to 1.5 times 10 to the 18 electrons per second when the bulb is by itself. And this comes from loop rule. So you'd have 2 EMF minus E L thin equals 0. All right, so we can then calculate. So NA thin U EMF over 2. So I thin is equal to NA thin U E thick. And we know that 1.5 times 10 to the 18 electrons per second is equal to NA thin U 2 EMF over L. Therefore, NA thin U EMF over L is equal to 0.75 times 10 to the 18 electrons per second. And it follows I thin is equal to NA thin U EMF over L times 8/5. And we have an expression for this that we can plug in. So this is equal to 0.75 times 10 to the 18 electrons per second, which is 8/5, which is equal to 1.2 times 10 to the 18 electrons per second. And we assumed that the lengths were the same. We assumed an ideal battery, and we neglected any connecting wires. So that is how you do the long part of 47.